Hello friends, in last session we have discussed how to prepare moment distribution table for two span continuous beam. Now in this session we will discuss how to prepare moment distribution table for three span continuous beam. For three span continuous beam you can observe first case where both end support A and D are simple. In second case, one end support is fixed and another end support, that is D, is simple, or D is fixed, A is simple, that comes in the same category. And third case where both end supports are fixed. Now how to prepare moment distribution table and how to solve it, that we will discuss. Here first case is taken where both end support A and end support D is assumed as simple. Now for preparing moment distribution table, I have assumed some random value as a distribution factor for joint B, which is zero point 0.3 and zero point 0.7, and for joint C it is assumed as zero point 0.2 and zero point 0.8. Let us assume some fixed end moment value also, because our aim is to just understand how to prepare and how to solve moment distribution table. So I have assumed randomly minus 40 plus 20 minus 30 plus 50 minus 60 and plus 60. Now how to proceed? First of all, it is required to release joint A and D because these joints are simple and we assume it fixed, that's why there is some moment is minus 40 and plus 60. So you are supposed to release it by applying the moment of equal in magnitude, opposite in direction. So here the moment of plus 40 is applied. Similarly at joint D, moment of minus 60 is applied. Now you are supposed to carry over half the moment with the same sign. The moment of 40 is carry over with the same sign, half moment. Similarly, half moment with the same sign is carry over at C. And we are supposed to write initial moments. After releasing whatever the moment will get, that is initial moment 0, that is plus 40 minus 30 as it is, plus 50 minus 90 and 0. Now after initial moment, if you observe, joint B and joint C are not balanced. We need to balance the joints B and C. So for balancing joint B and C, what you have to do, you are supposed to find unbalanced moment at B as well as unbalanced moment at C, and this unbalanced moment is to be distributed in the proportion of distribution factor with opposite sign. In this case distribution factor is 0.3 and zero point 0.7 and the moment is 10. So 10 into 0.3 is 3, 10 into zero point 0.7 is 7. The unbalanced moment is positive. When we distribute it, it is to be distributed with the opposite sign. So both side minus minus. Similarly, 40 is multiplied by zero point 0.2 and 40 is multiplied by zero point 0.8. Unbalanced moment sign is negative and therefore when we will balance, the sign is positive. Now there will be carryover. End A is simple, end D is simple. So for simple end there is no carryover, but the carryover is possible from C to B, half moment with the same sign, and carryover will be possible from B to C, again half moment with the same sign. Now if you observe, because of this carryover, joint B and C is again unbalanced. So we need to balance that. So this unbalanced moment is 4, that need to be multiplied with the distribution factor to balance it. So 4 into zero point 0.3 and 4 into zero point 0.7. The sign of unbalanced moment is positive, therefore when we will balance it with the opposite sign. Similarly, this 3.5 need to be multiplied with the factor zero point 0.2 and zero point 0.8. Sign is minus and therefore while distribution it will be distributed with the opposite sign. So due to this, again joint is balanced. Now remember, B to A or C to D carryover is not possible, but carryover will be possible from C to D or B to C. Half moment with the same sign, it will be carryover. Now again, due to this carryover, joint B and C becomes unbalanced, and unbalanced moments are this carryover moment 0.35 and 1.4. So this need to be multiplied with the distribution factor with the opposite sign is to be right. So 0.35 into 0.3, 0.35 into 0.7, and the unbalanced moment is positive, therefore while balance it is balanced with the opposite sign. This 1.4 need to be multiplied with zero point 0.2 and zero point 0.8. The sign of 1.4 is minus, therefore on both sides it will be plus. Again joint is balanced. Side carryover is not possible. So we will carry over again from C to B half moment with the same sign, and from B to C half moment with the same sign. So this is what our third cycle. One cross means one cycle. Now because of this carryover, the joint again becomes unbalanced. Now balance it. So balance with the opposite sign. So when we will balance with the opposite sign, minus 0.04, 0.14 into zero point 0.3. Similarly 0.14 into zero point 0.7. That moment we can write here. Now 0.13 into zero point 0.2, that moment we can write here, and 0.13 into zero point 0.8, that moment we can write here. And now three cycles are completed, joint is balanced, so we can go for final end moments. This is 0. Add this all and you should get at the end the moment of equal in magnitude opposite with the sign. If there is minor difference, then you can write the same moment on left and right side of the joint. Similarly, you can add the moment for joint C and joint D, and you can just write the final end moments. So hope this table is clear to you for three span continuous beam when both end supports are simple support. Now let me explain you next case. In next case, you can see one end support A which is fixed and another end support is simple. If you have any doubt or any question, you can ask me in the comment, or you can directly call me. You have my number, or even I will give it in the description also. Without any hesitation, you can call and ask me the doubt. Here I have assumed distribution factor as zero point 0.3 and zero point 0.7 and zero point 0.2 and zero point 0.8. Remember that these are assumed as randomly, and randomly some fixed moments are also assumed. Again I'll remind you, this is just to explain how to deal with the moment distribution table. Actual distribution factor and fixed moment calculation you can do depending upon given loading and the span of the beam. Now, end A is fixed, which we should not release, but end D is simple, that is to be released by applying the moment of equal in magnitude opposite in sign. And as soon as you will apply some moment, half moment with the same sign need to be carry over, and then you can write the initial moments. So you can write here initial moments as it is, just the addition. So you can observe initial moments are minus 40 plus 20 minus 30 plus 50 minus 90 and 0. Now what to do? You will observe joint B and C. Are they balanced? No. So calculate unbalanced moment. Write it in circle. Why we write it in circle? Because at time of addition this moment need not to be considered. So that's why this moment can be written in the circle. Now what to do? Yes, balance joint B and joint C. While you will balance, what is the procedure we have discussed? This unbalanced moment need to be multiplied with the distribution factor. For example, here 10 is to be multiplied with the distribution factor 0.3 and zero point 0.7, and write with the opposite sign. So unbalanced moment is minus 10. That's why plus 3 and plus 7. Similarly, 40 is to be multiplied with the distribution factor zero point 0.2 and zero point 0.8. Unbalanced moment is minus 40. Therefore, while distribute it with the opposite sign, that is plus. Now, remember, here end A is fixed. Whatever the moment you have applied at B, half moment with the same sign will be carry over at joint A. So half moment with the same sign can be carry over. The moment of joint B and joint C will also be carry over with the same sign. So you can observe plus 4 and plus 3.5. There is no carryover from C to D because joint D is a simple. So carryover is not possible. But because of this carryover 4 and 3.5, joint B and C becomes unbalanced, which need to be balanced. So for balance, again we will multiply unbalanced moment with the distribution factor, that is zero point 0.3 and zero point 0.7, and we will write with the opposite sign. Similarly, we can balance joint C also. So 3.5 is to be multiplied with zero point 0.2 and zero point 0.8, and with the opposite sign it is to be right. Now, when you carry over, again I repeat, from B to A carryover is possible, half moment with the same sign. From C to B carryover is possible, from B to C carryover is possible, half moment with the same sign. But from C to D carryover is not possible because joint D is a simple support, so carryover is not possible. Now due to this carryover, again joint becomes unbalanced, which need to be balanced. The 0.35 is to be multiplied with zero point 0.3 and zero point 0.7 and distribute with the opposite sign. Similarly, 1.4 is to be multiplied with the distribution factor and distribute with the opposite sign, and follow the same procedure, carry over this 0.11, half the moment with the same sign because joint A is fixed, carry over from B to C half moment, and carry over from C to B half moment. Always remember, when you carry over any moment, your calculator must be in the fixed mode. After decimal, it should give the answer in 2 digit. If you don't know how to do it, I request you to call me and get it clear how to do it. Now, whatever the carryover moments we have got, again need to be multiplied with the distribution factor. For example, here 0.14 is multiplied with zero point 0.3 and zero point 0.7. Value is plus 0.14, that's why minus sign on both sides. 0.13 is multiplied with zero point 0.2 and zero point 0.8, and again carry over. But we will not further carry over from B to C because it is said that minimum 3 cycle. One cross means one cycle. 3 cycles we have completed over here. So it is not expected to go beyond that. If you go, of course, you will get the correct answer, more correct answer, but time constraint is there. That's why we will stop at 3 cycle, and we can simply add the moments, and you will find that at joint B and C the moments are equal in magnitude, opposite in direction, and for simple support D the value of moment is 0. So hope the idea for second case, when one end is fixed, other end is simple, you can solve it. The same procedure is to be followed. Suppose end D is fixed and end A is simple, same procedure is to be followed. The end which is simple, that need to be released. After releasing, half the moment is to be carry over, and then we can proceed. Now quickly we will discuss third case. What is happened in this third case? You can see both the ends A and D are assumed as fixed, and in this case what to do, that we are going to discuss. Similar to previous case, the values of distribution factor and the fixed moments are considered, but here you can see joint A and D both are fixed. There is no step of release joint. When we release joint, when the joint is simple. If it is overhang or fixed, we are not going to release it. If it is overhang, then we will directly balance it. If it fixed, we don't do anything. We will directly go to joint B and C. So I again repeat, when both ends are fixed, your fixed moments are initial moment. There is no separate step of initial moment. When both ends are fixed, your fixed moments are initial moment. We'll directly go for joint B. Find out the unbalanced moment. Similarly, you can find the unbalanced moment for joint C, and then balance by multiplying with the distribution factor and distribute with the opposite sign. So you can observe it is balanced. Here also for C, same procedure is applied, multiplied with the distribution factor and distribute with the opposite sign. But remember that the end moments are to be carried over. Here from B to A is possible because A is fixed. C to D is also possible because D is fixed. So always remember end moment is to be carried over in the straight line. 3 half moment with the same sign, 8 half moment with the same sign is to be carried over. Now intermediate carryover, half of 2 is 1 and half of 7 with 3.5 carryover half the moment with the same sign. Now because of this intermediate carryover, joint B and C are becomes unbalanced and we cannot remain the unbalanced joint. We need to be balance it. Therefore again multiply with the distribution factor which is zero point 0.3 and zero point 0.7 and distribute with the opposite sign. Similarly 3.5 is to be multiplied by zero point 0.2 and zero point 0.8 and distribute with the opposite sign. Carryover at C to D as well as from B to A because both ends are fixed. Intermediate carryover from B to C and from C to B. Half the moment with the same sign can be carryover. Now again same, because of this carryover joint becomes unbalanced, so we need to balance it by multiplying with the distribution factor. So 0.35 is multiplied with zero point 0.3 and zero point 0.7 but opposite sign. So distribution with the opposite sign, carryover with the same sign. That rule you should remember. And end carriers are possible. You can see here end carriers are possible. Again for third cycle, carrier the half moment with the same sign. Again multiply with the distribution factor 0.3 and zero point 0.7 with the opposite sign. You can distribute it. Do the end carryover. But now 3 cycles are complete. Don't carry over intermediate carryover, otherwise joint will become unbalanced. Now you can directly go for final end moment. Final end moments you can write left and right here, and you can just add the moment and check your answer. I am very much thankful for giving your time and listening patiently. If you have any difficulty, you can ask in the comment or you can give me the call. My number is 8149424224. Thank you for watching the video. Thanks.